So we know this is an isosceles triangle, and an isosceles triangle has two angles that are the same. Can you tell it's those two? And two sides that are the same, so I know that this is 8 meters over here. Now, a lot of people then make the assumption that this has to be 90, the last angle, and the other two are 45. But it doesn't have to be 90. You can have an isosceles triangle that doesn't have a 90, and we don't know for sure what that angle is. So we can't use SOHCAHTOA unless there's a 90-degree angle. And the way to make a 90-degree angle is to draw an extra line. If I draw a line straight down here, that would make two 90-degree angles there. And with an isosceles triangle, when you draw a line straight down, you will split the bottom side perfectly equal. The reason we know that is these two triangles have to be similar triangles, because does it make sense that if it's a 90 and this angle, whatever this angle is here, has to be the same as that angle there? Because if these two are the same on the outside and these two are the same, then the last two angles have to be the same. And so since this side is 8 and this side is 8, these two triangles are the same. In mathematics, when we say two things are the same, two shapes are the same, we use the word congruent. So not only are they similar triangles, because all the angles are the same, because those two sides are 8, we know these are congruent triangles. They're exactly the same. And what that helps us do is, now that I have that those bases get split in half, it has to be 6 and 6. We have solved all the sides already. All that's left is to solve for the three angles, two of which are the same. Let's just put some letters here so we can talk about things when we're doing the question. I'll go A, B, C. And let's solve for angle A first. So if I'm looking at this angle A, that's part of this right triangle. And on that right triangle, what sides do I know? I know the hypotenuse will be 8. And this would be, for angle A, this would be the adjacent, right? Because it's right next to it. So if I have adjacent and hypotenuse, I'll go to my definitions and I'll say, which one, sine, cos, or tan, deals with adjacent and hypotenuse? Cos. So we write out the ratio. We write out the definition that cos of A would be the adjacent side over the hypotenuse. And we have cos of A equals 6 over 8. In order to solve for angles, we're going to need to take cos inverse of both sides, because that's the opposite of cos. And we take out our calculator. Cos inverse of 6 divided by 8, 41.4. The question did not say to how many degrees we needed to do this, so I did 1 decimal place. If you did 41 degrees, that would be fine as well, because it didn't say how many decimal places. Can you see that once you figured out that angle A is 41.4 degrees, because it's an isosceles triangle, we also know that angle C is 41.4 degrees. Those are two of the angles we needed to find. The last angle that we need to find is angle B. Now, angle B is both of those blue ones put together, right? Because we're looking at our original triangle. We needed to draw the height so that we could figure out one angle. But now that we've got angle A and angle C, you could find out angle B will be whatever is left from 180 once you subtract both angle A and angle C from there. Someone done this on their calculator? Is it 97.8? 97.2? Yes, 97.2. And that's our angle B. And I'll circle that one too. So we were able to solve the whole triangle. We found all the angles. We found this side as well, because it wasn't given, but that was easy because it was isosceles. And so in order to use SOHCAHTOA, we always have to have a right angle triangle. And if you don't have a right angle triangle like this isosceles one, you can draw and make a right angle triangle. What you learn in grade 11 is how to use sine, cos, and tan when you have triangles without a 90-degree angle. And we learn new rules for those ones as well. But that's next semester. Okay, so some time to work on your homework, and then we'll get started on the other part.